Most important topic in the control systems, transfer function. Transfer function, it is the ratio of Laplace transform of output variable to the input variable at all initial conditions are zero. All initial conditions are zero. Actual diagram for this is input, this is output. The Laplace transform of R of t will give capital R of S. Your Laplace transform of C of t give capital C of S. It will be converting time domain into S domain. Here linear time invariant systems only. Okay. Now we are going to deriving the transfer function. Here it is the ratio of Laplace transform of transfer function, Laplace transform of output variable to the input variable. So output C of S divided by R of S, you Laplace transform of output by Laplace transform of input. Here initial conditions are 0. The important formula for all the subject. This is transfer function. Transfer function is equal to C of S by R of S. Now we have to recall first of all the diagram. Here we have R of t, Laplace inverse R of t is equal to R of S. Next, linear time invariant systems. Output will be C of t. Laplace transform of C of t will be C of S. So now solve this. If input is impulse, here input is impulse response. Impulse. So impulse formula R of S is equal to 1. Now substitute this here. So transfer function is equal to C of S by 1, that is equal to transfer function is equal to C of S. I already told the output name can also called as response. Output also called as response. Here we given input as a impulse. So output impulse response. Impulse response. We have got impulse response is equal to C of t. C of t can be written as L inverse of C of S. This also can be written as what here we have got. C of S also can be written as transfer function. So finally impulse response is equal to L inverse of transfer function. Relation between impulse response and transfer function. Transfer function may also be called as a impulse response. This is main important, and this is also main important, and it can also be written as transfer function is equal to Laplace transform of impulse response. These two are main important formulas. Please note down it clearly. Poles and zeros of a transfer function. You have to note down point wise. Your first point, transfer function of numerator polynomial is known as zeros. Transfer function of numerator polynomial are called zeros, and denominator transfer function of denominator polynomials are called poles. Next one, the value of transfer function at a zero is 0, and the value of transfer function at a pole is infinite. What? The numerator of the transfer function is called zeros and denominator are called poles. The value of transfer function at 0 is 0 and at pole is infinity. 4 main points. And the next, the denominator of transfer function polynomial is called characteristic equation. That equation will be 1 plus sp1 into 1 plus sp2 into 1 plus sp3 and so on equal to 0. The denominator of the transfer function is called characteristic equation. Equation roots is equal to poles of the transfer function. Properties of transfer function. Transfer function is defined only the linear time invariant systems. It cannot be defined for non-time invariant systems, non-linear time invariant. Next point, transfer function is independent of input and output. It can. Now we have to draw S-plane. Here we have S-plane. If one or more poles and zeros lies in the right half of the S-plane is called non-minimum phase system. It means if any pole at 0 lies in the right, this is left, this is right, this is imaginary. If any root or pole lies in this area, right side area, then the system is called non-minimum phase system. Non-minimum phase system. If 0 or pole lies in the left half of the S-plane, then it is called minimum phase system. Okay. Next point. If polar 0 lies in the left half of the S-plane, left half of the S-plane, then it is called minimum phase system. Just you have to listen this carefully. I will give notes after the explaining of all points. Okay.